In this video, I'll show you how to get the balance of any Ethereum account, as well as how to track that balance over time and then make a graph of that using the Etherscan API. Now, this API is completely free. I'll show you all of the setup steps in this video, and I do want to mention that this video is not designed for beginners, so if you are a beginner programmer, you can try to follow along, but I am expecting that you have some familiarity with Python because I'm not going to be explaining all of the basic syntax. Anyways, let me show you a quick demo of what this program looks like. So I have an address. This will work for any Ethereum address, whether you own it or not. You don't need the private key or anything like that. And we're first going to get all of the account transactions. We're going to put those on a nice graph, and then we're going to look at the account balance. So let me run this code. It will take a second, and then it should give us a graph. All right, so there we go. We now have a graph that we can kind of zoom in on and look at all of the different transactions for. So you can notice here that it's saying this account here, one of the larger ones on Ethereum, has about 2 million Ethereum currently. Just look at the bottom right-hand corner of this graph and you'll see that. And if I close this, we see that it actually prints out the exact balance, which is 2 million. I guess this is 3,504.57 Ethereum. So quite a large number, and there's a ton of other stuff you can do with this API. I'm just going to show you these basic features, but once you know how to use the API, you can get all kinds of other data, graph all kinds of awesome stuff, and hopefully this video will be helpful to you. So with that said, let's actually get into the tutorial after a quick word from our sponsor. Before we get started, I need to thank BackTrace for sponsoring this video and tell you about the virtual game developer summit that they are hosting called Breakpoint 2. Breakpoint 2 is a free event happening from 10 a.m. to 6 p.m. on February 16th, and will be showcasing the tools and best practices developers rely on to ship quality games and apps. There will be speakers from companies like Unity, AWS, Epic Games, Helpshift, and tons of other industry experts, and these talks will discuss game quality, testing pipelines, performance issues, and share valuable tips and insights from developer visionaries and leaders. Breakpoint 2 provides an opportunity for practitioners in the game development industry to learn from each other, network, and share best practices and ideas through technical talks. Don't miss out on this awesome opportunity by signing up today for free from the link in the description. Thanks again to BackTrace for sponsoring this video. All right, so let's go ahead and get started. As I mentioned, we're going to use the Etherscan API. So the first thing we need to do is create an account on this website. Now, I will mention there's a bunch of other ways to get account balances and transactions. This is just the easiest way that I found. It's also completely free, so I figured we'd just use this for this video. So go to this website. I'll leave it in the description. It's just etherscan.io, and then you're going to want to sign in or create an account if you don't have one. Now, I already have an account, so I'm just going to sign in. And of course, if you don't have one, then just click to sign up. Okay, so once you are into your account, what you're going to want to do is go to your API keys, which should be in the other tab here. And then you're just going to create a new API key. So I'm going to click on add and then just give it a name. We could just do eth balance, if I could spell balance correctly, pi, whatever, name it whatever you want. I'm going to create that. Then it will give you the API key. You're just going to copy that key. And now we have all we need to use the Etherscan API. This is literally how simple it is. And now we can go back to our Sublime text window, which is what I'm going to use for this video. Feel free to use whatever editor you want. And we can just say our API underscore key, if we can put an underscore in here, is equal to, and then a string, and we're just going to paste in this key. Now I'm going to delete this key after this video, so it's fine that I show it to you. Great. So now we have an API key, we can use Etherscan. However, before we can start sending requests to this API, we need to install a few modules in Python. So what we need to do is open up our command prompt or terminal, depending on your operating system. If you're on Mac, it's going to be terminal. And we're going to type in the following, pip install, and then we want the module called requests. Now this is going to allow us to send an HTTP request to the API and then get some data and have a look at that inside of our code. So I'm going to say pip install requests. I already have it satisfied. For you guys, most likely you don't already have that, and so you need to install that. And then we also need to install matplotlib. This is going to give us that nice graph that we saw. Okay, so pip install matplotlib. Nice. Now, for some reason that command did not work for you, try pip3. So pip3 install and then matplotlib as well as request. And if pip3 is not working for you, another command you can try is python-m pip install and then request and matplotlib. And if this one doesn't work for you, try python-3-m pip install. If none of those work for you, I will leave two videos on the screen that show you how to fix the pip command, one for Mac and one for Windows. All right, so hopefully at this point you've installed request and you've installed matplotlib. So we're going to import those now. I'm going to say import, and actually, sorry, I'm going to say from, and this is going to be requests, import, and then we're going to import get. We just need to use a get request to get some information. And we're going to say from matplotlib import. This is going to be pyplot as plt. Now, this is just usually what we do when we want to access the graphing aspect of matplotlib. All right, so now that we've done all of these setup steps here, I'm just going to go back to the Etherscan website and show you some of the documentation for these APIs, just so you can understand how to read this and how to modify this code to access some of the other endpoints. So in case you're unfamiliar, an API is an application programming interface. Essentially, it's some resource on the web that allows us to send requests to it to get some data and then use that data in whatever way we want. So in this case, we can send requests to the Etherscan API. We can ask for transactions related to a specific account or a specific address. We can ask for smart contract calls. We can ask for the price of Ethereum. We can ask for all kinds of different stuff. In this video, I'm going to show you a very limited feature set of this API, but what I do show you will let you use the other endpoints of this API. So right now I'm just on the documentation. I'll leave this link in the description, and you can see that we have a bunch of different endpoints that we can hit. Let me make this full screen, related to accounts, contracts, transactions, blocks, logs, whatever. So I've clicked on accounts because this is the one that we want to use. And we can see here that there's a bunch of different endpoints. So we have one that gives us the Ether balance for a single address. And this endpoint requires that we send this type of request. So requests formatted in this way. We're going to do https://api.etherscan.io/API. The module we're accessing is account. The action is balance. This is the address that we want to get the balance for. And then we have a tag, which is going to be the latest balance, as well as the API key, which is our API key that we generated in kind of the first step in this video. Now it shows us what the request should look like. So we need to pass an address and a tag, and then it tells us the response that we're going to get. So we're going to get a status, a message, and then a result. And this result is going to be the amount of Ethereum in Wei, which is the smallest unit of Ethereum that we have. Now I'll show you how we can convert Wei to Ether, because obviously this looks like a massive amount, but it's probably not even an entire Ethereum. Anyways, I'll show you that in a second. Now we also can get the Ethereum balance for multiple addresses. We can get a list of normal transactions. We can get a list of internal transactions, all kinds of stuff. I'm going to show you how to use all of this. The point is that you can go to this documentation and very easily see how to call the API and what the response body is going to look like. And of course, if this is a little bit confusing, don't worry, we're going to go through all of it. Okay. So the first thing we want to do is we just want to get the balance associated with a single address. So what I'm going to do is just copy this entire string right here and paste this into my code, and then we'll start modifying it to actually make kind of a GET request URL that we can send. Okay, so let's go back to our code here. I'm just going to paste this in. So let's paste that in to run the code. And for now, I'm just going to put this inside of a comment. So let's make this a multi-line comment just so we can reference it. Okay. So this is the format of the request that we need to send, and the base URL is this, okay? So the base URL is the part before the question mark. All this stuff right here that you see is called query parameters, and these are kind of the arguments we're sending to this API. So this is the API URL, and these are the arguments that are going to give us the data that we want. So I'm going to say that my base underscore URL is equal to, and then in a string, I'm going to paste this right here, etherscan.io/API. Then what I want to do is write a function that's actually going to create a URL for me based on my API key, the tag, the address, all of this type of stuff, okay? So what I'm going to do is say define. I'm going to say make API underscore URL. And then inside of here, what I'm going to accept is a module, a action, like this, an address, and then something called quarks. Now we'll talk about what quarks is in a second, but for now, just put it in there. And then what we want to do is say that our URL, this will be a variable, is equal to, and then this is going to be the base URL plus, and then we're going to put an F string, and I'll discuss how an F string works in a second. And we're going to say question mark, module equals, and then this is going to be module. We're going to say ampersand, and then this is going to be action is equal to action. We're going to do another ampersand and say that the address is equal to the address. Okay, so let's explain what we're doing here. The point is that I want to have multiple API calls, right? I'm not just going to be calling for the account balance. I'm going to be calling for a bunch of stuff. And all of these API calls are going to require very similar things. We're going to need a module. We're going to need an action. We're going to need an address. And we're also going to need an API key, which is formatted like this. So I'm going to say API key is equal to API key. Now, what this function is going to do for us is it's just going to make a URL that we can send a GET request to so that we don't have to type out this entire thing every single time that we want to make a request. So what we're doing is we're adding the module, which is equal to whatever module we pass in here, the action equal to whatever action, right? The address, whatever address. And then these keyword arguments are going to be any extra query parameters, say like the tag that we might want to pass to a specific endpoint. Again, you'll see how this works in a second, but now what I'm going to do is I'm going to look at all of these kwargs, which are keyword arguments to this function, and I'm going to add them to this URL. So let's just explain kwargs quickly in case this is a bit confusing. When I call a function, these here are called our positional arguments, which are required, and we need to pass them to the function. So the module would be something like account, right? And then our action would be address, or sorry, not address, balance. I'm just copying what's up here. Okay, and then our address is going to be whatever it is. So let's just copy this address right here. Let's put it in a variable called address is equal to that. Okay, come on, paste. Okay, I guess I didn't copy it. So let's copy and paste. Okay, so we're going to put in the address. And then if I do something like tag is equal to latest, since this is not one of the positional arguments, it's going to be passed in as a keyword argument. Now, this ** kwargs allows us to accept an unlimited number of keyword arguments. So now I can go here and do something like x equals 2 or anything else that I want. Doesn't matter, I can pass unlimited keyword arguments. Now, inside of here, they're going to come in as a dictionary. So kwargs is going to be equal to a dictionary that's going to have keys and values. So if this is what I were to pass, tag equals latest and x equals 2, then the dictionary is going to look like this. We're going to have tag associated with latest and x associated with 2. So hopefully that makes sense. Just allows us to accept an unlimited number of keyword arguments. Then we get them as a dictionary and we can access them inside of here. So this is a very dynamic way to write this function. Now what I'm going to do here is I'm going to say for key, comma, value in, and this is going to be kwargs.items. Now, .items is going to give us the key value pair inside of a tuple for every single item in the dictionary. So if we had latest and this was associated with tag, or other way around, I should have wrote it the opposite way, we would have, let me just do it correctly here, tag and latest as one of the items, okay? Because tag is the keyword argument and latest is the value. So our key is going to be tag and our value is going to be latest. Hopefully that makes sense, but that's what items gives us. So what I'm going to do in here is I'm just going to look at the key and the value, and I'm going to add them in this kind of format, ampersand, whatever the name of the key is, equal to whatever the value is to my URL. So I'm going to say URL plus equals, and then I'm going to add an f string, which is an ampersand, and then I'm going to have inside of here the key is equal to the value. And since I forgot to explain f strings, what f strings are something that are new in Python version 3.6. You need to have 3.6 or above to use them, and they allow you to embed expressions directly inside of curly braces. So this way I don't have to do a bunch of concatenation. I can just write curly brace, module, curly brace, and then it will take whatever module is and just place it right inside of this string. So really easy. Okay, so there we go. We now have a function that can make an API URL for us, and it will add the API key and all of the other stuff that we passed to. So let's now try this out and see if it works. I'm going to say get address URL or get balance URL, is equal to make API URL. Okay, and we will just pass all of this, and then I'm going to print out the get balance URL, and let's have a look at it. Okay, so when I run this, we see that we have a URL now that has etherscan.io API. We have question marks stating we're going to have query parameters now. We have our module, we have our action, which is balance, we have our address, we have our API key, and then we have our tag. Perfect. So it just made a URL for us that now we can use to actually get this data. So I can actually just copy this URL and I can put it directly inside of my browser. And you'll notice here that when I do this, I get the result, which is the amount of Ethereum. I get OK, and I get status 1. But I don't want to do this in my browser. I want to do this from code. So now how do we do that? Well, let me get rid of this because we no longer need this. And what I will do now is that I have this get balance URL. I'm going to send a get request, which is kind of equivalent to me going to the URL in my browser. So what I'm going to do is say that my response is equal to, and then this is going to be get. And the reason I can use get is because I import it from requests here. And I'm going to put right here the get balance URL. Okay, because this is the URL that I want to hit. Now, what I need to do, if I want to get the data associated with this response, is I need to say data is equal to response.json. Now, JSON stands for JavaScript Object Notation, and that's the format that is going to return my data in. Now, in Python, JSON is really just a dictionary. So what this is going to do is give me a Python dictionary containing all of the keys and values in that response. So the status message, I guess if it was okay or not, and then the value, so the actual amount of Ethereum for this address. So let's now print this out. I'm just going to print out data, and let's see what we get when we actually send this request. Okay, so I run this, and then notice that I get status 1, message okay, and then result, and this is the amount of Ethereum. Now, all I really care about is the actual amount of Ethereum, so what I'm going to do here is say that I want to get the data at, and then, actually, I forgot what this was. Was this value? Actually, I think it was result, right? Yeah, I think it was in result. So let's print this out now and see what we get. And notice that we actually get the result, which is the amount of Ethereum. Awesome. So now we need to convert this to Ether because this is in Way, which is the smallest unit of Ethereum, and 1 Ethereum is equal to 10 to the exponent 18 Way. So what I'm going to do here is just make a variable at the top of my program. I'm going to say Ether underscore value is equal to, and this is going to be 10 to the exponent 18. And all I'm going to do is I'm going to take my result and I'm going to divide it by the ETH value or the Ether value. But I need to first convert this to an integer because by default, it's going to be a string. Okay, so I'm going to take my result, convert that to an int. This is the amount of Ethereum in Way. I'm going to divide this by 10 to the exponent 18, and that will tell me how much Ethereum I have, not how much Way I have for this balance. Okay, so let's go ahead and run this. And notice here that this has a very large amount of Ethereum, so 353,318 Ethereum. And if we want to verify that that is indeed correct, we can take this address right here. Okay, again, just a random address I'm using, and I can punch this into Etherscan. So let's paste it in here, and this is the amount of Ethereum that we have. Looks like that's about $1 billion. Nice, this definitely is not my wallet, in case you were wondering. Okay, there we go. So we now know how to get the balance for an Ethereum account. So since we've done this, let's just put this in a function so we can use it really easily. Let's say define get account balance. Okay, and then all we're going to take in here is an address, and we will do all of this. And then for the address, yeah, we can use address. That's good. Let's see, do we need anything else? Okay, I'm just going to say value is equal to this. So rather than printing this out, I'm just going to put it in a variable. And then I'm going to return the value, so this way we can just print it outside of the function rather than directly inside. So now if I wanted to call this, I would just say, eth is equal to get account balance. I'm going to pass my address, which is a variable. I'm just going to take this and put it a bit lower so it's easier to see. Okay, and then I'm going to print out my eth like that. And we've just done the exact same thing as before, but now we have a bit neater code. Okay, there we go. We get the balance. And now we can use this function for any single address that we want. We just have to pass a different address as a parameter. Perfect. Okay, hopefully that is clear. That was step 1. Hopefully you understand how to make an API call now. Again, all we're doing is using the get method from request. We're then getting the response. We're looking at the JSON, which is going to be the data associated with the response. We're getting the key in the dictionary that we want, which is result. We're going to convert that to an int, divide that by the Ether value. That gives us how much Ethereum we actually have. We return that from the function, and then we print that out. Nice. So now that we have done that, what we want to do is get all of the transactions associated with an Ethereum account and then put those on a graph. So to do that, I'm going to make a new function, and I'm going to say get, and we'll say transaction, if we could spell this correctly, I think that's right, get transactions, yeah, that's fine. Okay, and we'll pass an address. So now let's go back to the website. Let's have a look at the transaction API and what we need for that. Okay, so get Ether balance. No, that's not what we want. We want get a list of normal transactions. So first, let me just explain what is meant by normal. So a normal transaction is a transaction that happens between 2 different Ethereum addresses. So me sending you money or you sending me money. That's a normal transaction. An internal transaction, which you can see is right here, is a transaction that occurs with a smart contract. So we're going to want to get both the normal and the internal transactions so that we can actually graph the historical value of an Ethereum account. I'll discuss more what I mean when we start doing all of this, but the point is we want both the normal transactions as well as the internal transactions, because what we're going to do here is we're going to look at the very first transactions and start keeping track of how much Ethereum is in the account based on all of the different transactions that have occurred. Now, there is actually an easier way to do this because all we're trying to do is graph the balance of the Ethereum account over time. However, it's a pro API. So I'll show you if I go all the way down here. Get historical Ether balance for a single address by block number. This is exactly what we want to do. However, it's pro, and I don't want to pay for this. So rather than us paying for it, let's just do it ourselves and write some code that uses the free features. Okay, so that's what we're doing. So if you're wondering why I'm going through all of this, it's because I don't want to have to pay, and I don't want you guys to have to pay either. Okay, so let's first look at get a list of normal transactions by address. So let's copy this into our code, and let's do a similar thing to what we did before. Okay, so let's just paste this in here. This needs to be a multi-line string or multi-line comment. Okay, so we want the module to be account. We want the the action to be transaction list. We need the address. We need a start block, an end block, a page, an offset, optionally a sort, and then our API key. So inside of here, I'm going to say get underscore transactions underscore URL is equal to, and then this is going to be the make API URL, and we're going to pass in the account. We're going to pass in tx list as the module, right? For the address, we'll just pass in the address. Then we're going to pass a start block. This will be 0. An end block. This will be whatever this end block is here. So this is just giving us the range that we want to get the transactions for. So you could filter this if you want to get the transactions between two different block numbers. We just want all of them, so we'll go 0 and then a block number that doesn't yet exist, so we get all of them. We need to pass a page and an offset. Now, the page is going to give us results. Now, the page is here because we could get a ton of results, and every request that we send can only give us a maximum of 10,000 transactions. So if we had, say, 20,000 transactions, then we'd have to send this request again with page equals 2 to get the second page of transactions. Now, I don't think any of you are going to have accounts that have over 10,000 transactions, so don't worry about it, but I just want to explain why that's there. So we're going to say page is equal to 1. The offset is going to be how many transactions we actually want to get. I believe that's what it does. Yeah, I think that's how many transactions we want to get. So let's just go with 10,000, which is the maximum. And then we want to pass sort. So if we pass sort ascending, then that's going to give us the transaction that came very first. When I say first, meaning like the earliest possible date first, and then the last transaction last, which is what we want. And then we had one other thing. I think it was just the API key though. Let's see. Yeah, just the API key, which we already handled. Okay, great. So we've done all of that. So this should be good to go now. And let's just see what happens if we send a GET request to this URL and just look at the raw data. So I'm going to say that my response is equal to, and I'm going to say GET, and then GET transactions URL. And then let's just print out, and let's make a variable here. Data is equal to response.json. Let's just print out the data, and we'll print it. Actually, yeah, we'll just print out the data and have a look at what this is. Okay, so let's go full screen. Let's not create a new file. Let's run this code. Well, we need to call this function first. Okay, so let's do that first. So let's just get rid of this call. Let's say get transactions like that. Let's pass our address, and let's see what happens. Okay, so we get a bunch of data here, which is going to be all of the transactions, right? There's a huge mess of transactions here. So let's just go up to the very top. And we can see we have status, message, and then we have result. And result is a list, and these lists contain all of the different transactions. Okay, this is a huge amount, but let's start by just looking at one individual transaction and see what that looks like. So to do that, I'm going to say the data is equal to response.json at result. That's going to be a list, right? So I can just access the first element in the list to look at one individual transaction. So let's look at data 0 here. Let's run this again, and let's see if this is a little bit easier to comprehend. Okay, so here we can see that we have a block number, a timestamp, a hash, we have a nonce, transaction index, we have a from, we have a to, we have a value, we have gas, the gas price, we have a bunch of stuff here. So what I want to do is I want to loop through all of these transactions and just print out a few details. I want to print out the to, the from, the value, which is the amount of Ethereum that was actually sent, the amount of gas used, the timestamp. I want to print all that stuff. So let's do that. So I'm going to go here and I'm going to say for TX, standing for transaction, in data. Now recall data is a list, so we can just loop through it. And I'm going to say that my to is equal to TX to. Okay, my from, not form, my from is equal to TX and then from the value, and this is going to be from ADR just so we don't mirror the from word in Python. Okay, I'm going to say value is equal to, and then TX at value. I'm going to say the gas is equal to TX at gas used. Okay, and is there anything else we want to print here? To, from. We probably want the timestamp, so I'll say time is equal to TX at timestamp, and then we can print out this data. So I'm going to say print, and we will say to, colon, to, print. We're going to say from, colon, from underscore ADDR. Okay, we're going to print. This is going to be value, which is the amount of Ethereum that was sent in this transaction. Say this is value, if I could type properly, and then we'll print gas used. This will be gas used, or just gas, okay, and then print time, colon, and then time. Okay, I know I went pretty quickly there, but this is pretty straightforward code. So let's run this now and see what we get. Now, so I'm just going to print one thing to make kind of a separator between these different addresses here. So let's just print this so we can kind of see a separator between them all. All right, so let's run this, and what do we get? Key error timestamp. Okay, the issue here, sorry, is that timestamp has a capital for an S here. So let's fix that, and now let's run this and see what we get. All right, so we get a bunch of data here. Let's have a look at some of these transactions starting from the very top. All right, so I'm at the top here. Now, this one's a bit weird. We don't have a to address. I'm not going to talk about exactly why that happens. That's getting deeper into Ethereum. Anyways, though, we have a to, we have a from, we have a value, we have the gas used, and we have the time, which is actually a timestamp. So what I want to do now is convert this time to an actual date, because this isn't very meaningful, right? I mean, maybe some of you can understand what this timestamp means. I definitely cannot. And so I want to see it in, like, you know, date or day, month, year, right? That's ideally what I want to see. And then maybe the hour and the minute it occurred as well. We're going through, we can see all of the transactions. For most of these transactions, they're only sending 0 or 1 Ethereum. And actually the 1 here, I believe, is in way. So not even in Ether, they sent 1 way. Now, that's just this account. I guess a bunch of the transactions they're doing, they're not actually sending data with them, or they're not sending any Ethereum. I don't know why, but that's what they're doing. All right, so now what I'm going to do is convert this timestamp to a date. And the way we're going to do that is by using the datetime library. So I'm going to say from datetime, import datetime. And then I'm going to say that my time here is equal to, and then this is going to be datetime dot, and I think this is from timestamp. I just have to look at my code here. Okay, from timestamp, we're going to pass this in, and I think this should be good. Okay, actually, we need to convert this to an int, sorry, because this is going to be a string, and now this should actually give us a proper date as opposed to a integer. Okay, so let's try this here, and let's see what we get. And there we go. So we get 2022, 02, 01, and then the time that this occurred at. Perfect. We are now getting the correct time. All right. So I don't really like using this address for this example because a lot of the transactions don't actually send any Ethereum. So let me find a different one, then I'll be right back. All right. So I just found another address here that's going to be better to use because the transactions make a bit more sense than the other account we were using. So let's just run this code now with this new one and see what transactions we're getting. Okay, there we go. So see, the value is much higher now, so they're actually sending Ethereum with a lot of the transactions they're doing. Now this is in way, so what I want to do is convert this value to Ether. So let's do that. We already know how to do that. I'm just going to take the value, I'm going to convert this to an int because by default these are going to be strings, and I'm going to divide this by the Ether value. Okay, let's run the code now, and let's see what we get. And notice now that we actually get the amount of Ethereum, and they're sending a very large amount of Ethereum with a lot of their transactions. This account is one of the whale accounts, so that makes sense. Perfect. Okay, so now what I want to do is I just want to do a better calculation for the gas, because if I go back to here, you're going to see that the response for getting the normal transactions, we have gas as well as the gas priced and the gas used. Now, what we actually care about here is the gas used, and we want to multiply this by the gas price to determine how much this actually costs, okay? So we need to take the gas used and multiply it by the gas price. That just gives us how much it actually costs to, well, do this transaction. So let's fix that now, because right now when I say gas used, that's not exactly what we want. We want to have, I guess, gas cost, okay? So I'm going to take my gas, I'm going to convert this to an int, and I'm just going to multiply this by the int of, and then this is going to be tx at, and this is going to be gas price like that. Okay, and then we're going to divide all of this by the ether value, and I don't need parentheses because order of operations is the same here with multiplication and division. Okay, so let's try this now, and let's see what we get. And we see, gas, yeah, it's gas price, not gas price. Okay, let's fix that. All right, now we actually get a more useful gas price here, and you can see that the price of gas is super expensive on Ethereum. Okay, so there we go. Now we know the gas cost as well as the value, and so this actually tells us how much it costs someone to submit a transaction. So now that we have all of this data, what I want to do is start making a graph that will give us the balance of an Ethereum account over time. Now to do that, we need to start from the very first transaction, and at the very first transaction, our account balance is 0. So before we have any transactions in the account, we have a 0 balance. Then we're going to look at every single transaction. We're going to determine if we're sending money or receiving money, and then we're either going to subtract money from our account or add money to our account. Now, the thing is, when we are sending money, what we are actually doing is we're paying a gas price as well as the value of our transaction. So we need to add those two values together and subtract that from the current balance in our account to get an accurate account balance. However, when we're receiving money, we're not paying the gas. Whoever sent it was paying the gas. So we only care about the value, and we're going to add that to our account. Hopefully that makes sense. Well, the way we're going to do this is we're going to say current underscore balance is equal to 0. And then we're going to increment or decrement this balance in this for loop based on every transaction. And since our transactions are ordered by ascending, what that means is that we can just go through all of them in the order we get them, because the first transaction we get is the very first transaction that ever occurred in this account. Hopefully that makes a bit of sense, but that's how we're going to do this. We're going to loop through all the transactions and kind of increment or decrement the current balance. We're going to store all of these results in a list. So we're going to say balances is equal to that. We're also going to say times is equal to this. So we keep track of what time each balance occurred at, and then we'll be able to graph that data. Okay, so we have 2 from value gas time. I don't want to print out this data anymore. What I want to do is determine if we were the one who were sending money or receiving money. Now, if we were the ones who were sending money, the from address is going to be our address. If we were the ones receiving money, then the to address is going to be our address, right? That's the way the transactions work. So I'm going to say money underscore in is equal to, and then this is going to be the from address. Actually, we'll just do this. We'll say the to is equal to, and then address, okay? Now address is the parameter right here that we passed in. Now, what we do need to do is just convert the address to lower cases, as well as the to address, because we might have them in upper cases and that might mess it up. So we're just going to convert both of them to lower cases to make sure that we're getting an accurate comparison here. Okay, so this tells us if we have money in. So we're going to say if money in, then what we want to do is we want to take the value and we want to add that to the current balance. So we're going to say current balance plus equals value. Otherwise, if we're not having money in, if money is coming out, then what we want to do is say the current balance minus equals, and then this is going to be the value plus the gas. Okay, because again, if we are sending a transaction, we're paying the gas. We need to take the gas used and the gas price, multiply them together, divide them by the ether, and then that tells us how much it costs us for gas. We add that to the value, which is how much Ethereum we sent. That gives us an accurate current balance. Okay, there we go. So that's what we're doing for current balance. And then we're going to say balances like this. Oops, come on. Can I type properly here? Balances dot append, and we're going to append whatever the current balance is. And we're also going to say times dot append, and we're going to append whatever the current time is, because we're going to use one of these lists for the x-axis, the other one for the y-axis. I actually did them in the opposite order. This is going to be x, this is going to be y. Okay, Now, we also have to remember here that we're only looking at the external or normal transactions. We also want to look at the internal transactions. We're going to add that to the equation here in 1 second. So let's just run the code for right now, but let's print out what the current balance is at the end just to see how far off we are when we're only looking at the normal transactions. Okay, so let's run all of this here and see what we get. And we get a balance of 200,000, 2 million, and then 3,504 Ethereum, which I think was almost exactly what the actual balance was when we got the account balance. Now, the issue is this might work for this specific account because it might not have any internal transactions, but there will be a lot of accounts that have a ton of smart contract calls, and we need to account for the value being sent there and all of those types of transactions. So we need to add that in here. And the way we're going to do that, so we're just going to go back to Etherscan here, is we're now going to get the list of internal transactions, and we're going to combine that with the list of normal transactions and then loop through all of them in a similar way. So this is what we have here. We have TX list internal. So the only change here is that we just have to pass TX list internal as opposed to account for the URL that we want. And then we'll get a very similar response. Okay, so let's check this out. We're going to go now, after we get this, we're going to say get internal underscore TX underscore URL. And then this is going to be make API call. And let's actually copy all of this. Okay, so let's just paste this here. And then rather than getting the TX list, we want TX internal list. I think that's what it was. Let's just check this here. TX list internal. Okay, so I did it wrong. Let's fix that. Okay, TX list internal. So again, it's just the exact same thing as what we had up here, except now we're doing TX list internal to get all of the internal transactions. But we still need to send a request. So we're going to say response to is equal to get, and then this is going to be get internal TX URL, or sorry, get, and then pass here, get internal TX URL. And in fact, I shouldn't really be calling these get. I'm just going to put transaction URL and internal TX URL just because that makes more sense. And get balance URL, yeah, we'll just make that balance URL. Okay, anyways, now that we have that, I'm going to say data2 is equal to response to.json, and then we're going to access the result as well. So now we're going to get one list of results and another list of results. They're both going to be ordered. However, what I want to do is combine them. So I'm going to say data.extend data2. This is going to take all of the elements in data2 and simply add them to the current data list. However, now we're not going to have these sorted because we're going to have all of the normal transactions, then all of the internal transactions. So I want to sort all of them so that we have a correct list here. So I'm going to say .sort. Actually, let's do this after. Let's go data.sort. And then we want to sort all of these by the key, which is equal to lambda. I'll explain this in a second. So lambda x colon x at, and then timestamp. And then make sure you have a capital S here for timestamp. Okay, so what we're doing is we're getting all of the regular transactions, all of the internal transactions right here. We're then going to extend our data list by data2, so our normal by our internal. Now, it's no longer going to be sorted because we have all of the new transactions we got at the end of this list. So we need to resort this list. So we're going to say data.sort. The key we're going to sort by is going to be every element's timestamp. So that's what this is doing. We're saying, okay, for every element, which is going to be represented by X, we're going to grab the timestamp and we're going to sort by that timestamp. And we can convert this to an int just to make sure we're going to get a correct sorting here because by default, this is a string. Although I think it will work even if we didn't convert it to an int. Okay, so now we should get every single transaction and loop through all of them. Let's run this though and see if this is working. All right, so it looks like it is working. We got 200,000, or we got 2 million, and then again, 3,504. Apparently, I cannot read numbers. However, I will tell you that this will not work the way it is if we have any internal transactions. Now, this account doesn't have any internal transactions. I should probably find one that does. However, if we go and we look at the response here, we can see that we only have gas and gas used. We don't have a gas price. So I just need to fix something in my code to account for the fact that my internal transactions don't have a gas price on them. And we're just going to have to use the gas used as how much gas was used, okay? Because the gas won't really have a price with the internal transactions. I understand it's a little bit weird, but we just have to account for the fact that we don't have that key in these responses. So what I'm going to do here is say if, and I'm just going to say gas price in and then TX, then we'll calculate the gas using this. But otherwise, we'll just calculate the gas by being the gas used and then divided by the ether value, okay? Divided by ether value. So this will work the exact same way as before now. Again, we're just going to account for the fact that the internal transactions don't have this gas price key. Okay, so we're almost done. We now have all of the data that we need. We're getting an accurate current balance. What we want to do now is actually graph this using matplotlib. Now, this is super easy to do. All we're going to do is say plt.plot, and we're going to plot as the x-axis are times and the y-axis are balances. Now, I might be passing this in the wrong order. We'll see in 1 second. But I'm going to pass times and balances. Now, since these are the same length, this will work because we're going to match every balance with each time. And then if I want to show this, I just have to say plt.show. Okay, so let's do plt.show. Let's run this, and let's see what we get now. All right, there we go. We get a nice graph, the same one that I showed you in the demo at the very beginning, and it looks like all of this is working. So our y-axis is going to be the Ethereum amount in our account, and then the y-axis is going to be the amount of time, or the date, right? So if I go here, you can see that we're at the correct balance, just about 2 million Ethereum in the account. Again, an absurd amount of Ethereum. Okay. There you go. So that is really all I need to show you for this video. Now, hopefully this showed you how to work with the Etherscan API and how you can easily ask for more information. Again, we were calling different API endpoints very easily because of this nice function we made, make API URL. You can reuse this function in as many ways as you would like, call all of the different types of endpoints, get that data, look at the data, so on and so forth. I showed you how to get the account balance as well as how to look at all of the transactions and then how to get the balance over time from those different transactions. Now, again, a bunch of other stuff you can do. I hope you guys mess around with the API and make some cool stuff. I will mention that I'm sure a lot of you want to actually get the Ethereum value, like the dollar amount in your account, not the amount of Ethereum. Now, to do that, for every single time that you have, you would just have to look up what the Ethereum price is. I believe you can do that from the Etherscan API, and then you would replace your balances with the actual balance multiplied by whatever the price of Ethereum is, and then that would give you the dollar amount of your account on every single day that a new transaction occurred. Now, you also could do this over every single day. You guys can kind of figure it out from here because I've given you the building blocks to build a type of project like that. Anyways, with that said, I am going to wrap up the video here. I hope you guys found this helpful. If you did, make sure to leave a like, subscribe to the channel, and I will see you in another one.